GeopByte.
Let us take the another important problem. Look at this problem. It is asking like this. A block of mass 2 kg. Look at the block. That block, let it be of mass. Mass of the block is given 2 kilograms. 2 kilograms is placed on a inclined rough surface AC. Look at the angle between the base and plane. This is the base. This is the base. This is the plane. This is the plane. Angle between the base and plane is 30 degrees. And coefficient of friction mu given 1 by root 3. Okay. G value. G equal to 10 meter per second square. The net force on the block will be. What is the net force acts on the block? For that, we need to mark the what normal reaction line. This is the contact surface. Let me change the color of the marker. This is the contact surface. Normal to that contact surface, there is a normal reaction. This is the normal reaction line. But look at the self weight. Self weight is acting vertically downwards through the center of gravity with a magnitude mg at an angle theta with respect to normal reaction direction. Then it is developing two component of weights. This is mg cos theta and this is the mg sin theta. It is asking net force acts on the block will be, right? Net force, since the block is moving in this particular direction, the frictional force is acting in this direction. That frictional force is equal to mu times the n. But look at the diagram. The normal reaction n must be balanced by mg cos theta. mg and n and mg cos theta both are in the same line but opposite direction. That's why n must be equal to mg cos theta. Then frictional force F equal to what? Mu n. It is equal to mu mg cos theta. Mu mg cos theta. Okay. Now the net force. Here ask to say net force only. The net force equal to look at the mg sin theta. Mg sin theta is acting towards down in this direction, but frictional force is opposite. Minus frictional force. It is equal to mg sin theta. Frictional force is what? Mu times the n. It is equal to mg sin theta minus mu times the n equal to what? Mg cos theta. M is given. For the m value? M value 2 kg, mu 1 by root 3. Here 2 kg, G value 10, sin 30, theta is given 30 degrees, minus mu 1 by root 3 given, mg, m is 2 kg, G 10 cos 30 degrees. You simplify it. Here it is 20 divided by sin 30 is 1 by 2, 20 by 2 minus 20 by root 3 into cos 30 is what? Root 3 by 2. Root 3 cancel. Finally, it is 20 by 2 minus 20 by 2. 20 by 2 minus 20 by 2 is equal to 0. Therefore, net force acts on the block is 0. Look at the options. Look at the options. Option D. Option D is absolutely correct. Okay. Similarly, let us take the another important problem. Look at the problem. Asking like this. The angular acceleration of a body moving along the circumference of a circle is the angular acceleration of a body moving along the circumference of circle is always along the axis of rotation. Therefore, option A itself is absolutely correct. Okay, it is concept oriented question. Simple question. Understood clearly? Yes. Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. What is the maximum acceleration maintained by the moving car when a body placed on the floor of the car is under stationary condition? Okay. and the coefficient of static friction between the body and the floor of the car is 0.15. Here coefficient of friction mu equal to 0.15. Look at the G value given 10 meter per second square. Okay. For that, let me mark the body placed on the floor of the car. This is the body placed on the floor of the car. Now, the force may be acting on the body in this particular direction, but the frictional force is acting opposite to that external force. Then, the body which is placed on the floor of the car remains stationary only when the external force must be equal to frictional force. But what is the frictional force? Frictional force F equal to mu times the normal reaction. For that, better to mark the normal reaction. This is the contact surface. This is the contact surface. Perpendicular to the contact surface, normal reaction is developing. Look at the center of gravity G. Through that center of gravity, the self weight of the body is acting vertically downwards with magnitude mg. This mg must be equal to n. N must be balanced by mg. Therefore, frictional force F equal to mu into N equal to what? Mg. Mg. So, force, external force equal to what? Mass times the maximum acceleration. It must be equal to mu into M into G. Here, this mass is cancelled on both sides. Therefore, maximum acceleration equal to mu times the G. Mu given 0.15, G given 10, 0.15 into 10, 1.5 meter per second square. That is the maximum acceleration maintained by the car. Look at the option D. Option D is absolutely correct. Understood clearly? Simple problem. Okay. Similarly, let us take the another important problem asking like this. In the diagram shown, the normal reaction force between the 2 kg and 1 kg. Look at the diagram. There are three bodies placed on the inclined plane. Three are maintaining different masses 1 kg, 2 kg, and 3 kg. It is asking what is the normal reaction force or normal reaction between the 2 kg and 1 kg. For that, you are asked to take the G value, G equal to 10 meter per second square. Okay, the total mass, your total mass is equal to total mass equal to 3 kg plus 2 kg plus 1 kg is equal to 6 kilograms. Okay, then first let us decide the acceleration. For deciding the acceleration, net force, look at the forces, mg, mg total mass times the g, let me write it clearly, total mass times the g sin theta is acting in this particular direction, in this direction, mt total g sin theta is acting in this particular direction, plus f2 is also acting in the same direction, right? But f1, look at the f1 acting opposite, minus f1 is acting opposite, minus f1 must be equal to net force. That net force equal to total mass multiplied by acceleration. M total is what? 6 into G 10 into sine. Look at the theta value. Sine theta 30 degrees plus F2 18 minus 60 equal to total mass, that is 6 kg times the this net force must be equal to mass times the acceleration multiplied by acceleration. That is 60 divided by 2 sin 31 by 2 plus 18 minus 60 is equal to 6 times the A. Here it is 30 plus 18 minus 60 is equal to 6 times the A. 48 minus 60 equal to 6A. Here it is minus 12 equal to 6A. Therefore, acceleration A equal to minus 12 by 6. That is equal to 2, right? Of course, minus is 2 meter per second square. Or acceleration A equal to, I am taking only magnitude, 2 meter per second square. That is the acceleration maintained by the combined system. Okay. Then it is asking what is the normal force between the 2 kg and 1 kg. For that, it is better to mark the right 1 kg mass. This is the 1 kg mass, 1 kg mass. Okay. Now, with respect to 1 kg mass, here 80 newtons is acting in this direction. F2, F2. This is the 1 into G into sine mg sine theta direction, sine theta direction, and look at the normal force. It will be N. Normal force N. That N is how much? N is how much? Now here this N minus N minus N minus G sine theta, G sine theta plus minus F2, because both are acting in the same direction. Minus F2 must be equal to mass times the mass of that particular body times the acceleration. Acceleration. Here N minus G10 sine 30 minus 18, F2 is given 18, equal to mass is 1 kg, 1 kg, acceleration is 2. Acceleration 2. N minus 10 by 2 minus 18 equal to 2. N minus 5 minus 18 equal to 2. N minus 23 is equal to 2. Therefore, normal force between the 2 kg and 1 kg is 2 plus 23 is equal to 25 newtons. That is the normal force acting between the 2 kg and 1 kg. Understood clearly? Look at the options. Look at the options. Option A itself is absolutely correct. Okay? It is also equally important problem. Okay?
GeopByte.